Good evening. In the second part of the semester, we're going to start off looking at structured query language. The first part of the semester, we learned about data modeling, how to organize our data into tables so that we can retrieve it at a later time. With SQL, we're going to learn the skills we need to actually retrieve data from our database. And we'll be doing some hands-on work in class with the university database that we downloaded the first day of class. So let's start. So we're going to, in this lecture, go over the basic commands and functions of SQL, how we can use SQL to manipulate data, that is to add records, modify them, or delete them, and also how to retrieve data from a database. So there's two types of command there's two categories of commands in SQL. The first is a data definition language, and this is where we actually create tables in our database and create attributes or fields in those tables. The second category of SQL command is a data manipulation command. That includes inserting records into tables we have created, updating records in tables, deleting records in tables, and then selecting records so that we can view them or put them in reports from our tables. There are minor differences between SQL with the major vendors. Microsoft, Oracle, MySQL all have minor differences, but I would say probably 85% of the SQL commands work without any modification between the systems. So here's a look at the type of commands we'll be doing in terms of data definition. We'll be creating a table with the create table command, and in it we'll designate certain fields as primary keys and certain fields as foreign keys. And we can even do things like add indexes in order to improve performance. Here's a list of the data manipulation commands. This is where we use SQL to insert records, select records. In other words, we want to retrieve them from a database. And we can retrieve them with a filter, and that's where the where clause comes in. Rather than retrieve all the records, maybe we only want to retrieve the records for the computer science department. So that's where we would use a where clause. We want to say where department name equals computer science. We can also do group by. So if we want to find out things like average salary, maybe we want to find out average salary by department in addition to overall average salary. And that's where the group by and having come into play. Of course, update is where we're going to update records, and delete is where we'll delete them. So we have looked at creating database models and having tables with data that can store data. And in these lectures coming up, we'll learn how to actually put data into a database and then retrieve records from that. So when we create a table in the database management system will actually create physical storage space on your disk drive. This is going to be very different from one vendor to another. The create table command is probably going to be identical, if not almost identical, between the vendors. So we deal at a logical level. We want to say create a table, and the database management system handles the particulars for putting it onto the disk for us. So we can look at also when we create a schema, creating attributes with that schema. And those attributes can be numeric, character, date, or several other built-in SQL data types. So when we create a table and we have attributes in it, we'll have create table, and we'll also have attribute names and they'll be capitalized. The features of the table, one of the things we might specify is not null or unique. Not null means that it's required that when you enter a record, that field in the record have data. So a particular field will be not null. We can also specify unique. So for a primary key, we would probably want a unique specification and a not null. In other words, we do not want the same value for two different records for this attribute. And we don't want the user to be able to not put a value for the attribute in. So these are all part of the create table command. And the general syntax is create table, table name, and then the attributes in the table. So again, we would designate a primary key with a not null and a unique. Not null ensures that the column, or a synonym for column is attribute, and a synonym for that is field. In other words, the field in the record can't be blank. That's what it means when it says it does not accept nulls. Unique means that you can't have the same value in that column in two different records. Each record has to have a unique value in that column or that field. You can also specify defaults. So for the other non-key attributes, you might specify defaults. If the user doesn't put in a value, then you put a default value in for them. You can also check attribute values that are put in to make sure they are within constraints. So you might check to see that salary is between 20,000 and 100,000. So primary keys result in a unique index, and then the database will make sure that no other value with that, no other record has that value for their primary key. You can also create an index on other fields in your record in order to improve performance when you search by those fields. And there's a create index command that does that for us. The command to insert records into a table is known as the insert command, and its syntax is insert into table name and then a set of values. And so that would be the values for the fields in that particular table. Let's take a look at the select command. The select command is where we actually select records from the database. So its syntax is select column list from table name. Now we can also use a wildcard character, the asterisk, to indicate all column names. So let's take a look at how we do this. I'm going to share SQLite. Okay, so I'm in SQLite, and well, let me get out, and I'm going to start it up, SQLite 3 umbc.db, and I can check the tables to make sure I've got them, and I do. So now I'm going to do something called .shell CLS, and that'll clear my screen. Let's take a look at the SQL commands, the select commands, I mean. So let's say select star from student. Oh, I had heavy finger there. There we go. So I selected the records. Now I can do a couple of things to make this a little bit better. So I can go .mode and now I'll do that select statement again. Now I've got a little bit better organization, but I can also say .header on, and I'll do a shell and clear screen, and we'll do that again. Select star from student, and now it's a little bit neater for us when we look at it. Next, let's just select one column from the student table. So we'll say select ID from student. And you can see that now we are just selecting the ID. And I will clear the screen again. And then we'll say select ID, comma, name from student. So here I have two fields, ID, comma, separating it from the second field, name, and I'm getting those from the student table. And I get the ID and the name. Now, another thing we can do is we can look at the schema of our student table. So I can type in .SEHEMA student. And it tells me how I made the table. So I have create table student, and then of course parens, ID, name, department, and of course the data types, total credits, primary key, and foreign keys, and so on. So, and you can also, of course, copy this information out of here and use it as a template for your own database, creating tables. Okay, let's switch back to our lecture. Now, I mentioned that we don't always want to select every record in a database. So sometimes we only want to select records that meet certain criteria. And in that case, we can use the where condition. So let's take a look at doing that. So here we are back in our SQL database. I will do .shell CLS to clear my screen. Then I'm going to say select star, meaning all the columns, from student, and I hit return. I haven't put my semicolon at the end, so it's still going to accept commands. And then I say where total credits greater than 90. Now I put my semicolon. It knows I'm finished giving it instructions and it executes that instruction. And you'll see here, I didn't select all the students. Here, I just selected the students whose total credits was greater than 90. Okay, and let's go back. Now, we can insert records into a table as well. And of course, we've looked at the select command, and the select command basically has several parts to it. We have the select column list from table list, and optionally, we can have a where clause where we specify a condition or set of conditions. So we have where condition list. So let's take a look at instructors instead of students. So let's take another look. We'll go back to SQL and I'll do .shell CLS select star from instructor where, oops, where salary greater than 50,000. And so now I have the set of instructors that have a salary greater than 50,000. So let's spend a little bit more time on these comparison operators that we use in the where clause. We've looked at something like the greater than, students who have total credits greater than 90, instructors who have salaries greater than 50,000. So let's take a look, a more comprehensive look at the relational comparison operators. So we can use an equal sign, select students where department name equals business. Less than, select instructors where salary less than 100,000. And of course, greater than, not equal, same thing. Select students whose total credits is not equal to 90. Sometimes when we get large SQL queries, it becomes tedious typing the table name over and over and over again. So we have the ability to give the table an alias name, where then we don't have to keep typing it over and over and over again. And that's very easy to do. When we do our from table name, we can say from table name as alias. Let's take a look at that. Okay, so we'll clear screen. And here we're going to say select star from student as S. So we've given the table name student an alias, and the alias is S. That'll save us a lot of typing in a very complex query. Now, obviously, in this one where I'm just demoing how to do it, it's not a complex query, it's a simple one, but you get the idea. where total credits greater than 90. Semicolon indicating that we're done with our command, and then SQL then executes the command, and voila. So there's some precedence in the operators. When we get large, complex queries, we're going to be using a lot of comparisons, a lot of multiplications, divisions, additions, and subtractions. And there's rules in SQL and in other programming languages known as precedence rules. Which one of these operators do we do first? Well, one way to make sure you can specify the way you want it done is you can use parentheses, and things in the parentheses will be done first. But the order of precedence is the arithmetic operators, plus, minus, multiplication, division, and raising to a power. Now, in addition to relational comparisons, equals, less than, greater than, we can combine several relational comparisons with logical operators. And the common logical operators are or, and not. So we could say something like, find the students where the department name equals business and total credits is less than 90. And that would give us, all the people who are not seniors in the business department. Likewise, we could say, find all the instructors where department is equal to computer science and salary is greater than 50,000. So again, we've combined two relational comparisons: salary greater than 50,000, department name equals business, and we combined them with an and. An and means both conditions have to be met. An or, you can combine things with an or, and that means that either one of them, if either one of them is met, then you get a record output. When we have strings in our database tables, like name, for example, is a string, then you may not want to type out the whole name, especially if it's a long name. You may only want to type out the first couple of letters and then have it match on all names that start with those letters. And you can narrow it down like that. So the like command is something that lets us do that. So we'll say like, and then we'll give a wildcard. So we want to find all the instructors whose name is like E %, and that's going to give us all the instructors whose name starts with E. Let's take a look at that, in fact. Okay, so I'm going to shell CLS. And if you're on the Mac, it would be .shell space clear. So we'll go select star from instructor where name like apostrophe E %, and it gives me the two people on the faculty whose name starts with E, Einstein and El Sayed. So you see the syntax of it is we have where name, instead of doing a greater than, equals, or less than, we use like. Then we have in quotes, because it's a string, we have apostrophe and then the pattern we want. We want everything starting with E. And then the wildcard character in SQL is the percentage sign. And then we close it out. But we can also alter a table. Once we've created a table, it isn't cast in concrete. We can change it. So we can do things like add a column, we can drop a column, and we can even change column characteristics. So we might want to change the column name, we might want to change some other attributes about it, and we can use the modify to do that. So the basic syntax for that is alter table, table name, modify, and then you give the column name and the data type that you want to do. We can add a column or drop a column as well. Now, there's something known as a transaction, and we'll be covering transactions in a later lecture. But with a transaction, you can have a whole series of updates. And if something fails, you can roll back all the updates. So in other words, you want a whole block of work done, or you want none of it done. Common example for something like this is, let's say you want to transfer $50 from account A to account B. You want both things done. You want to subtract $50 from account A, and you want to add $50 to account B. So that's two separate actions. So you create a transaction with those two separate actions. If one of them fails, then the whole thing's rolled back. So you're not left with the case where the first part, you subtract $50 from account A, is successful, then the system goes bonkers and you didn't complete the second part. Your database is then not consistent. So transactions are how we handle things like that. We can also copy a table from another table, add, modify columns, drop columns. We can also drop a table itself. The drop table command is going to get rid of the table from the database. There's another command called the delete, and that removes records from a table, but it doesn't get rid of the structure of the table. Then we have some commands that are aggregation commands. They let us do aggregation type work for analytics, counting, finding max and min values, calculating averages. So these are common, summing up values. So these are common things that we do in analytics, and SQL gives us a way of doing them. Because in a sense, SQL is often the data store that is used to store data that is used in data analytics or business analytics. Now, oftentimes it'll be stored in things like Excel spreadsheets, but more often than not, you're going to find it in a database. And so the database has the commands built in to do a lot of that type of aggregation. There are times when you want to sort the records coming out of your select statement. And so an order by clause is going to enable you to do that. So you can use an order by clause to sort by one of the columns in your list, from your select statement. Let's take a look at that. So let me do shell.shell CLS. I'm going to say select star from instructor, order by department, department name, semicolon, indicating I'm finished typing in my instruction, and SQL will then execute it. Now notice I sorted by department name. Look at the order of the records now: biology, computer science, electrical engineering, finance, history, and physics, music. Sometimes when we do a select statement, we'll get multiple values. So for example, if I select department name from student, I'll be getting a lot of duplicate business and duplicate computer science and so on. If we only want to show the unique set of values for a particular column, we use the distinct modifier. So let's take a look at that. Shell CLS. Let's do select department name from instructor, semicolon. And notice that we have duplicates. Well, in fact, let's make it even more obvious by doing an order by. So I'm going to say select department name from instructor, order by department name. So now notice that we get duplicates for our departments. I have 3 computer science, 2 history, 2 finance, 2 physics. If we don't want that, what we can do is say select distinct. So select distinct department name from instructor, semicolon. And now I only get the unique names of the departments in our instructor table. Here's some of those aggregation commands I referred to earlier. These are going to be used in data analytic type operations. We'll have a count, a min, a max, a sum, and an average. And with that, we can perform some operations on our database. So let's take a look at that. So let's say select, oops, let me get, there we go. Select count star from instructor. And this is going to tell us how many instructors we have in our instructor table. We can say select average salary from instructor. And so the average salary in the across all instructors is close to $75,000. Now, let's say the university is worried about its budget and they want to find out how much all the salaries totaled together are. Select sum salary, oops, from instructor. So we are spending $898,000 on salary. What's the minimum salary? Well, select min salary from instructor. The minimum salary is 40,000, and we can do the max salary. $95,000. So again, these are commands we can use to do aggregation. Now, sometimes we want to do more than aggregation on the entire table. Sometimes we're going to get requests from management that say things like, we want to know what the average salary by department is. That way they can see who the big spenders are in terms of the various departments at the university. So we use a group by to do that. And when we do a group by, say, department name, then what's going to happen is SQL is going to give you the aggregate for each different value of that particular column. So like department name, instead of giving us an overall average salary, it would give us the average salary for each department. So let's take a look at that. And again, the group by command lets us do that. So I'm going to clear things off here. So select department name, average salary from instructor, group by department name. Now we can see the average salary for each one of the departments. And it looks like physics is the big spender. $91,000 is their average salary. Music is the most beneficial to the bottom line. It only has an average salary of $40,000. Again, this is a type of aggregation capabilities you have in SQL to help do analytic type work. We're also going to talk about some more powerful commands to do analytic work where we can do pivot table type operations in a database. We'll reserve those for a later time. Now, a having clause, remember how we had a where clause that let us filter based on values in the table? A having clause lets us filter by the group by operation. So average salary is not in our department, in our instructor table. But we can filter by average salary using the having clause and a group by clause. So we do a group by, that'll give us the average salary by department. And then we can say having to filter out. We only want to look at, you know, those departments that have an average salary greater than 80,000. We want to do a review. So let's see how that works. So we'll go through our select name, average salary from instructor, group by department name. Now we add in having average salary greater than 79,000, let's say. So now it shows us who the big spenders are. Didn't show us all of the various departments like music, where the average salary was 40,000. It gave us the big spender departments. And we can then say, well, we need to take a closer look at electrical engineering, physics, and finance and see what's going on there and why they have such high average salaries. Again, this is the type of aggregations. And there's a whole set of online analytical processing extensions to database management systems that really let you do a lot of sophisticated analytics. But these are kind of built-in things that we can take advantage of in an introductory course. Now, we can also join tables together. Remember that when we did our normalization, we said if we had a table that had a problem with a normal form, in other words, we had a table hidden within a table, the solution was to decompose that table into two tables. Well, that means we're going to, to get information, we're going to have to join those tables back together. And we do have commands that let us do that. So we can take advantage of the alias so that we don't spend a lot of time typing table names over and over and over again. And again, the syntax is from table name alias or from table name as alias, depending on the database vendor. Here's a case where there could be some differences. We'd also have recursive tables by using aliases where we join a table to itself. Now, we're going to take a look at joins in our next lecture. So, any questions on what we've covered tonight?